Welcome to the second part in Fuse and MCBs in household circuits. In this video we'll pick up from where we left in the last video, and I remember I told you I will share with you some of the stories of hostel days and the pranks that children play in hostel. So let me continue with some more theory, and let me tell you what they do so that you can better appreciate them. So here's a summary of what we talked in the previous video. The fuse protects devices or wiring from excess current being drawn, and a fuse rating is a numerical value. So for example, we can say, hey, this fuse has a fuse rating of about 2 amperes or maybe 5 amperes. What that means is it's a max permissible current. If your current is greater than 5 amperes, for example, which is the fuse rating, the fuse will melt. So this guy will melt, and the circuit will open up. So if this fuse melts, then the circuit will open up. And the third thing is always your fuse is the first thing that you connect in the live, and then the switch, and then third the device, and then the other end of the device is usually the neutral. So let's see some visuals of fuse. So a fuse comes in various forms. So let's first look at the fuse that you typically will find in the entry of your house, where power comes from your electricity company. So you have the live and the neutral, which is coming from the transformer. So you have the live and the neutral that's coming from the transformer. So what we do is we connect this live to one end of, these are called the porcelain fuse. This is porcelain. Yeah, this material is porcelain. Yep, porcelain. I just looked up the spelling. Okay, so the other end of the fuse is coming out like that, right? So your live comes out, and this is what we drew using mnemonics. So we drew that, hey, when we draw a fuse like this, right? So this whole piece that we see is what we are seeing here, right? And on the other end, what we do is we connect a small fuse wire, and this is called the fuse wire. This is let me write this here, fuse wire, right? So if an excess amount of current, this fuse wire is designed for a particular fuse rating. So for example, this could be a 15 ampere fuse wire. What that means is that if current is above 15 amperes, this will break. So if current is less than 15 ampere, what you will find is, as you plug in this switch, the current will flow. It will make the connection. So this is one kind of fuse that you will find typically. Then you will find the other type of fuse that you will find is this one. Here you see this fuse, right? These are typically glass, and in the middle you see there is a wire. So the fuse wire is here, and let's see here, this is a 3-pin socket. So you can imagine that this is a 3-pin socket. Usually your right pin is live. So as the live, as the live comes in, you have a fuse here, and then you supply the live through the live, right? So you supply this to your equipment. So in case you're drawing excess current, this fuse will melt. So this fuse is here, and you also find the same fuse in your power strips, or in your power points. So everywhere you will find the fuse. Here the fuse is here, right? In the power board, the fuse is somewhere over there, right? So I hope this gives you familiarity with the fuse, and always, irrespective of how the fuse is, what type of fuse is, we always use this as a symbol of fuse. And then so now let's look at the different fuse rating that typically you will find in household circuits. So you will find that the fuse that you put up in the entry of your house, these are about has a fuse rating of about 50 amperes, and sometimes it may vary from 30 to 60 amperes, but usually the current that is coming inside your house is probably about 50 amperes. The fuse rating is about 50 amperes. That's a max current that the electricity board will allow you to draw from the line. And then you will find these for your geysers and heaters, etc., which is high power equipment. You find this big socket. So these are big socket which requires big plugs and big pins. The smaller plugs won't fit inside these sockets. These are 15 ampere lines. So if you know that in your house, when the current goes and they switch on generators, so usually gen sets, UPS won't give power. This is only from electricity board. The reason is because there's a lot of current that these equipments draw, and usually gen sets and UPS can't, or it's difficult to support so much. Then you will find the normal power strips and normal equipments, your adapters and stuff like that. Those are 5 amperes. And here is a diagram for a 5 ampere socket. There's nothing to do with fuse, but just to illustrate that this 5 ampere pins are much smaller than your 15 ampere, which is quite big. Okay, so these are the typical fuse ratings you will find for different or 3 main classes of fuse rating that you will find inside your house. So moving on to another piece of safety equipment called MCBs. So MCB stands for miniature circuit breaker, and these also are alternative for fuse. So these are alternative for fuse. The problem with the fuse is that once the fuse wire melts and it breaks the circuit, it's very difficult to get a fuse wire of exactly same fuse rating, and you have to rewire your fuse. You have to wire your fuse again, in what we saw previously. So to avoid that, we use MCBs, and MCBs work on a different principle. So MCBs also have ratings. So we can say these have current or current rating. I don't know what they exactly call. They may call it as maybe they call it as fuse rating itself. So these also have rating. Let's say these MCBs come at different, as 32 amps, 16 amps, etc. What that implies is if the current drawn is above max rating, then the MCB trips. We say the MCB trips. That means that this whole thing goes down, and if you need to bring on the power again, you need to pull it up. So that will bring back the power again. So MCB works on this principle. You don't need to rewire like what you do in fuse. When it trips, you can fix the problem inside the house and put on the switch back, and that will bring back the power, right? And the advantage of MCB is that the tripping time, so the tripping time is very small. So this tripping time is on the order of about 25 milliseconds. Now for fuse and all, it may take up to a second to melt, and by that time your equipment may actually or be in trouble. So tripping time is very less in MCBs, and that really helps a lot. So now finally to the story that I promised I will tell you in the previous video. So in during the hostel days, there's a very common prank that children play, which is what they do is they inside the holder they would put a 1 rupee coin, and this 1 rupee coin is actually what it is doing is it's shorting your circuit. So nobody knows it, right? Until so let's say this is here is a live, and this is your neutral, right? So let's say your you do this. So let's say your warden or somebody who comes and unknowingly switches on this switch, right? They switch on this switch. So when they switch on the switch, what happens is, of course, these lines are coming from your main control, and the main during olden days, or there would be either a fuse or there would be an MCB, there would be an MCB, right? So let me finish this circuit. So when they unknowingly switch on this circuit, what happens is you're drawing a lot of current, right? Because the I is very, very high, because this resistance is very, very low, right? Let's say it's 1 ohm. Then you will try to pull about current of V divided by R, that is 220 volts divided by 1, that's 220 amps. That's a lot of current. So these MCBs will trip and the fuse will melt, and usually teachers have no idea of how to fix this thing, so they will have to wait for the electrician the next day to come and fix the problem, right? So without power in your hostel, you can kind of have fun. So that's the whole idea. But I urge you not to do it, because if you do it, I know you did it because you heard this. So okay, so have fun. See you in the next one. Bye.